Yes, class. So in the last class, we had completed with the thermal properties of matter. So now I'll start with kinetic theory. This is a very short lesson. We'll try to finish it in today's class only. So in Friday's, the mock test that you have, so for Friday's test, you'll be having the syllabus as kinetic theory and thermal properties. The mock tests that are occurring, I think this will be the fourth mock test. And I hope you all have received the marks of other mock tests, first and second. Last one only Hiba and Abdullah appeared. In the mock test 3, no, not in mock test 2, only Hiba and Abdullah had appeared. So Hiba was, I think your score was 22 or something out of 27, and Abdullah's was 24, like this. Just have a look once. So others also, Tarif, you also appear for the test that is going to occur on Friday. Now, see, in kinetic theory, first there are certain laws. So for perfect or ideal molecule system, there are certain laws given for different values of temperature, for different conditions of pressure. So first law is known as the Boyles Law. You just have to do all these laws in brief. So I'll tell you, note down this much, and this will be sufficient for you. Because in this lesson, you have very small topics that are included in your syllabus this time. So Boyles Law gives the relationship between pressure and volume. So if the temperature is constant, see, if temperature is constant, then pressure is inversely proportional to volume. It means P multiplied by V, their product will always remain constant. And how will the plotting of the graph be? See, this is P versus V. A hyperbola will be obtained because both are inversely proportional to each other. So if you increase the volume, see, if you increase the volume, pressure decreases. If you decrease the volume, pressure increases. So this is the first law that is known as Boyles Law. What is this law? It gives the relation between pressure and volume. So if temperature remains constant, temperature remains fixed, pressure is inversely proportional to volume. Then second law you have, this is known as Child's law. So this gives the relationship between temperature and volume. So here if three quantities are there that will be exchanged. One is pressure, one is temperature, last one is volume. So now if pressure is remaining constant, which are left? Volume and temperatures are left. So volume is directly proportional to temperature. So if volume increases, temperature also increases. If volume decreases, temperature also decreases accordingly. So it means if you write V divided by T, this remains constant. V divided by T, this remains constant. Fine. V divided by T, this remains constant. So now if you plot the graph between V and T, so if you plot the graph between V and T, so volume versus temperature, they'll be directly proportional to each other. Because now see, you're increasing volume, let's say at this point, temperature is increasing. Take another point, now volume has increased. So here temperature has also increased. So volume and temperature are directly proportional to each other. Last law that you have, this is known as Gay-Lussac's law. Here, which quantity will remain constant? Now here, volume will remain constant. So in the first case, I'll repeat it once. So here, volume remains constant. So now pressure and temperature are directly proportional to each other. It means if pressure increases, temperature decreases, pressure decreases. If pressure increases, temperature also increases. And if pressure decreases, temperature also decreases. So this will also be a very similar graph. So similarly here as well, if you plot P versus T, it will be directly proportional. This will be directly proportional. You keep on increasing the value of pressure, value of temperature will keep on increasing. So these are the three laws. One quantity will remain constant, like in Boyles law, temperature remained constant, pressure and volume were inversely proportional to each other. Right? In Charles' law, your pressure was constant, so volume and temperature were directly proportional to each other. And in last one, Gay-Lussac's law, you have volume as constant, so pressure and temperature are directly proportional to each other. First, note it down. See, in Charles' law, your pressure remains constant. The way in Boyles' law, we had temperature as constant. No, so value of pressure does not change. See, three quantities are there: pressure, volume, and temperature. So this remains fixed, and there's a relation between the other two. So in the above law, that was Boyles' law, both were inversely proportional to each other, pressure and volume. But the relationship between volume and temperature is such that they are directly proportional to each other. So if you double the volume, temperature will also get doubled because it is directly proportional to it. If you reduce the volume, temperature will also be reduced. Fine. So see, V is directly proportional to T. It means if you bring this in the denominator, or even if you replace it with a constant sign, this will be equal to or some constant T. So V, this T will come here. V divided by T will be equal to some constant. That is written as V by T is constant. Fine. So that the graph will also be linear graph, directly proportional. Understood, Tarif?
Understood.
Written till here, class? Or are you still writing? Let me move forward then if you all have written. Now see, you had all these gas laws separately. Now for perfect gas equation, if I'll combine all of these, what was the first one? First one was that pressure and volume are inversely proportional. That is, PV is constant. Right, if I combine all of these, let me write it separately. What have we studied till now? It will be a conclusion also. Pressure is inversely proportional to volume. Pressure is directly proportional to temperature. Volume is directly proportional to temperature. It means PV is directly proportional to temperature, right? You can conclude from here, no? PV is constant and both are directly proportional to temperature. So P into V is directly proportional to temperature. So if you remove the proportionality sign, you put a constant term. So here the constant that comes is R. PV is equal to RT. This equation, this is your equation. This is the universal gas constant. Fine. P is pressure, V is volume, T is temperature. But this is valid for only 1 mole. If let's say I have n number of moles, N moles are present. So equation will become PV is equal to nRT. This you will study in chemistry, or you must have studied in chemistry. PV is equal to nRT. I think in 11th standard only there's a lesson in chemistry. States of matter, I think, where you have all these parts. So PV is equal to nRT is the perfect ideal gas equation. So what is this constant R? Okay, 11th only you have. No, okay. So questions are just, if a question comes from this topic, it will be exactly from chemistry question like this, formula based. And this is not also very important from your physics perspective. So this R is what? 8.314 joules per mole per Kelvin. And if you have to write this unit in calorie, CGS, that will be 2 calorie per moles. Actually, this becomes candela. Let me write it as candela only. This will be moles and this will be degree Celsius. Fine. So this is in the SI unit. This is in the CGS unit. So I have combined all the laws that gave the real gas equation. Note down this. Then I think next topic that we have is, yes, postulates. That is the most important. And in most of the questions, this only topic comes, postulates. Do this, then we'll do that. Remember, class, this is not so very important, and this you can solve using your basic knowledge of chemistry as well. And if questions come, it will be direct. No, Tharif, not candela. I wanted to say degree Celsius. By chance, I said candela. Candela is actually the unit of intensity. We are using calorie, not candela. This is calorie. Calorie is the CGS unit, not CGC, CGS unit of joules, energy. Energy, SI unit is joules, and you write calorie. Fine. Erg is also written. Calorie is also written. So I have written it in terms of calorie. Not candela. That I said by mistake. I wanted to say degree Celsius. Candela is the SI unit of intensity. class, these are 6 postulates of kinetic theory. This you have to remember and learn properly. See class, this is very, very important, and do mark it as important in your notes as well everywhere, because it can be asked to you in your examination also. There are lots of chances this postulate part is asked, because in most of the papers, this is only asked. This is the usual question that is asked. Either the laws for very basics, laws are given, or postulates are given. So this is the most important topic, I'll say. So what are the postulates, or what are the assumptions of it? So it says that whatever is a sample of gas, it consists of large number of identical molecules for statistics to be applied. This means if you have taken a container, so all the molecules will be present. Large number of identical molecules, all the molecules, identical molecules will be present. That is what is meant by this first postulate. Molecules will be present, identical molecules will be present, large number of identical molecules. Fine. Second postulate says that total volume is almost negligible. This means they are very far apart in comparison to their sizes. It means these are so small molecules, no, that when you will see, you will think that both the molecules are at this much distance from each other. But when you will observe it microscopically, you will see that one particle is here, another particle is here, because their volumes, their sizes are so small that even the distance between them appears to be greater. That is what is meant by the second, that they are very far apart from each other in comparison to their sizes. Fine. They are very far apart in comparison to their sizes. Third postulate says that these molecules, these individual molecules are, see, I have also drawing the spheres only. I am also drawing it in the form of circle only. I could have drawn it in the form of a square, a cuboid, rectangle. No, because these are treated as hard spheres. So these are basically spheres, these molecules. And they exhibit perfect elastic collision with each other and with the walls of containers. So here the key term is perfectly elastic collision. Remember, when we were doing work, energy and theorem, that time I had told you when we were doing collision, and I had told you that this will be in detail, means this you have to remember in the kinetic theory lesson. So this is what it is, and rest of the details you have already learned how to calculate, what is the formula for perfectly elastic, inelastic, everything you fine. So they collide with each other as well as they collide with the walls of container. Fine. Then say when they're colliding, apart from that fact, there is no force exerted. No force is exerted by the molecules on each other on other molecules. So there is no force exerted apart from collision. During collisions they can. And they obey Newton's laws of motion. Means one particle will be accelerating, acceleration will be there of a molecule. Fine. Action, reaction forces will occur. If action and reaction forces will occur properly, inertia and all the laws of Newton's laws will be obtained. Then you have law of equipartition of energy. This is also a very small topic, easy topic that you'll be able to manage. Note down the postulates, then I'll tell you law of equipartition of energy. This is also not very difficult. This is also a small topic, but this is important class. Please remember all these. See class, now law of equipartition of energy. This basically means that whatever energy is associated with per degree of freedom of molecule. Degree of freedom we have not done, no? After this, I'll do degree of freedom first. So this is what energy associated. Energy associated with each degree of freedom. I'll explain this to you. With each degree of freedom per molecule. So formula of energy, no, this is half. Do not go into the definition so much. Degree of freedom, I am going to tell you. In detail, I'll tell you this degree of freedom because this is important. So this is half kBT. This is the energy. Half E is energy. This is the energy that is associated. Half is the constant. Kb, this is known as Boltzmann constant. This is Boltzmann constant. So what is the value of this Kb? I hope you all have written the postulates. See, what is this Boltzmann constant? This you have to remember throughout for your even entrances. This part is important. See here what is meant by Boltzmann constant. Boltzmann constant is basically when you divide the value of the gas constant that you have with the Avogadro's number. This comes out to be around 1.38 into 10 to the power minus 23 joules per Kelvin. Do mark it as important and to be learned. This you have to learn on your own. This value you have to remember. So sometimes kinetic energy is also written as half kBT. Not you always as half mv square, sometimes as half kBT as well. Fine, this is half kBT. Now see, this is valid for one molecule. This is valid for one molecule. If you have to write it for 1 mole, see, for 1 mole, energy will be half kBT, right? Multiplied by Na. For 1 mole, you multiplied by Avogadro's number. So multiplied by Avogadro's number. Keep the value of Kb from here class. That becomes R by Na into T and here into Na. Avogadro's number gets cancelled. This becomes half RT. So this is valid for 1 mole. For 1 molecule, you will use this formula. For 1 mole, you will use this formula. And I'll tell you degrees of freedom. But before that, see, if energy is asked, we write it as NFRT by 2 for n number of moles. So this you will be confused because you have not done degree of freedom. Here F is the degrees of freedom. F is degrees of freedom. This I'll tell you. Just note it down till here. I'll tell you what is meant by all of this. Degrees of freedom. Copy this part. I'll tell you degree of freedom. Then only it will become clear. After this, I'll do degrees of freedom only. That is small, very easy, very, very easy. Degrees of freedom by the name only you can do. But just note it down and I'll tell you. C class. Now degrees of freedom. This is important. Just understanding this, then law of equipartition will also be clear to you. See, monoatomic, when I say a molecule is mono, it means only a single atom is present. Like if I give you example, for monoatomic, any particle you take where only a single molecule is present. Let's say one single molecule of hydrogen or one single molecule of nitrogen. This is known as monoatomic. But do you ever think hydrogen and nitrogen exist in such a manner? Hydrogen and nitrogen. No, hydrogen, you never say H or you never say N. You always say dinitrogen and dihydrogen. That is H2 and N2. Not monoatomic. This part is, this is diatomic. This is called a diatomic. Fine. So when two molecules, they combine together, when two monoatomic molecules combine together, that becomes a diatomic. So like H2, you say, one molecule of nitrogen and with another molecule of nitrogen, that becomes N2. So H2, N2. These are diatomic molecules. Fine. Again, this is written as monoatomic. Just a second. So if more than two atoms, then we call it as polyatomic. Like if I'll tell you one, again I'm taking one hydrogen, one oxygen, one hydrogen. So HHO, that becomes H2O. So this is clear. Monoatomic, diatomic, polyatomic. By the name you can understand. Now what is meant by degrees of freedom? So it means number of ways in which molecules can move, the planes in which a molecule can move. So one formula is there. F is equal to 3n minus k. F is the degree of freedom. To find out whether how much degree of freedom a molecule has, you use this formula. This is degree of freedom. 3 is a constant. N is the number of particles in the system. Number of particles in the system. And K is independent rotations among particles. Independent rotations among particles. So this is the formula for degree of freedom. This is also used whenever required. So what is meant by this? This is now the formula part. No, what is actual meaning? These are the axes with you, x-axis, y-axis, z-axis. So if a molecule is kept in such a manner, or a molecule has such a direction where how much rotation or permittivity is given, what is the degree of freedom? Let's take it one by one. For monoatomic, let's take. Fine, let's take this one for monoatomic first. Let's take this one for monoatomic. So n will be equal to 1. For this, you have to remember, number of molecules will be 1. This is very simple. But value of k, this you have to remember. Value of k you have to remember. How much rotations are allowed? No, this you have to remember. So if it's a single molecule, it won't rotate. K will be 0. Now put it 3 into n. In place of n, put 1. Then minus 0. So what do you get? Degrees of freedom become 1. Degree of freedom is 1. It means that this can is 3. So this means that it can rotate, move in all the 3 planes. That's it. It can just translate. No rotation, no vibration, nothing. Single translation movement is permitted. Find degree of freedom. Now, if we talk about diatomic. See, number of molecules will become 2. Now, one rotation is permitted in diatomic. Fine, because for rotation we always need axis, and here we do not have axis. So when you put the value, when you put in the value f, that becomes 3 into 2 minus 1. So 6 minus 1 is 5. So f is equal to 5. 5 degrees of freedom are permitted. It means one rotational, this is the molecule, it will rotate also, this will translate also in 3 axes, in x-axis, y-axis, z-axis, it will rotate also in both the axes, that will make 5. Fine. Lastly, you have triatomic. Till triatomic, just do, that is enough. Triatomic means 3 molecules are there, 3 atoms are there. So n will be equal to 3, and see, value of k is 3. K is also 3, both are 3. So if you put, that will be 3 into 3 minus 3. So that will become 9 minus 3, that is 6. So f is equal to 6. Fine. So it means it can 6 degrees of freedom. This means it can translate, it can rotate in all the planes, and it can vibrate also. Vibration, you can leave it. It's like 3 rotations are possible in the 3 axes and 3 translation motions that make it for triatomic molecules. So this is what is meant by degree of freedom. So when we were talking about law of equipartition of energy, now come back to this. Degree of freedom, this formula simply says that energy is number of molecules multiplied by degree of freedom multiplied by the constant multiplied by temperature divided by 2. This is used for the molecules. If I say monoatomic, so you will put F as 3. So that will become 3 nRT by 2. Fine, F's value will become 3. If I say a triatomic molecule is there, you will put F as 6. If I say a diatomic molecule is there, you will say F is 5 nRT by 2. Like this only. This is what is meant by degree of freedom. Yeah. All right, note down this degree of freedom part. First, write about the molecules and atoms, then write about these. Whatever doubts you have, you can type in between or text me, or you can unmute yourself. See, this derivation also comes sometimes pressure exerted by the whatever ideal gas if you have or any type of. So here what you have to calculate is basically, see, if I have taken a container and I have so many molecules present. So every molecule will be having its mass, every molecule will be having its velocity. Either velocity will be towards the left side or velocity will be towards the right side, right? So velocity will also be there. So mass and velocity, if you multiply, we get a quantity. Can anyone tell me what is this quantity when you multiply mass and velocity? Mass with
Pressure.
velocity. Yes, Tarif?
Miss pressure.
Momentum. It's momentum.
Momentum.
Okay, momentum.
Okay.
So momentum you will have to calculate. Just remember, this is a small derivation. No question will be there specifically from this. If the question is asked, directly mention this entire derivation. That's why I'm saying step by step, no, learn it with me. So momentum along the x-axis, let's say, if I'm talking about, or total momentum I'm saying. So that will become mass into velocity along the x-axis, right? This is momentum. So what is the change in momentum? This is the individual momentum. I am wanting to write the change in the momentum. All right, class. So how do we write the change? We always write it, no, final minus initial. That's how we write. So here also we'll write it as, let's say, we have taken one direction as negative. We have taken this direction Vx as negative. All right, this direction I have taken it as negative. So this will become m into minus Vx minus m into plus Vx. Right, this is final momentum. This is initial momentum and their subtraction. Final momentum minus initial momentum. All right, so the change in momentum, this will become 2mvx. Actually, minus 2mvx. This minus is also there. No? Minus mvx minus mvx. Here we are left with minus mvx minus mvx. That became minus 2mvx. Now, force is what? Remember, these obey Newton's law, as we have read postulates in the postulates. So force is equal to rate of change of momentum. Right? So force is momentum divided by time. What is momentum? From here. From here, you can say momentum is minus 2 mvx divided by time. That is what is the force. So I have the force. Now what you were mentioning, Tarif, pressure. There's a relation between pressure, force, and area. I have told you all this in fluids. Pressure is force by area. So I have the value of force with me. This is the value of force. See, I calculated momentum. Force is momentum by time. So I got the value of force. Now I want to find out the value of pressure, and pressure is force per unit area. So the formula, ultimate formula is 1/3 and just remember this you have to remember. I'll tell you what are the meanings of each term. V square, this is the pressure exerted, actual pressure exerted. This is the formula that you have to remember, because we'll be using this formula to find out the root mean square speed also we'll write, and the final formula. See, what is P? This is the pressure exerted. Pressure exerted. 1/3 is a constant. Small m is the mass of molecule. This derivation is not there in your syllabus, this part. So just remember this formula. Mass of molecule. V is the volume of the box or the container. Volume of the box. N is total number of molecules. Total number of molecules. And V is root mean square speed. Now, what is root mean square speed? We didn't do this, right? Root mean square speed or velocity, we didn't do this. What is this? So see, if let's say there are so many molecules, just understand this. Let's say this is one molecule. having velocity v1. This is another molecule having velocity v2, another molecule v3 having velocity v3, v4. Let's say up till nth molecule I have having velocity vn. All these are velocity. What is written? Root mean square. It is written in this order: first root, then mean, then square. But what you have to do, you will write, for you it will be first squaring, then you will take out the mean, and at the last you will put the root. Go in this manner, then only you will be able to find out the answer. So first squaring, v1 will become v1 square, v2 becomes v2 square, v3 becomes v3 square, v4 becomes v4 square. So till nth molecule is vn, vn will become vn square. Second step, so squaring is done. We are through with squaring. Second step, mean, to find out the mean. Mean value, you know how to calculate the mean value. You add all the quantity and divide it by the number of quantities that are present. So V average, this will be equal to V1 square. See, number of molecules I have divided V1 square plus V2 square plus V3 square plus V4 square. All the molecules that are present, I have divided by the number of molecules. So this way I have calculated the mean value. So squaring is done, then mean calculation is done, and last is putting the root. So what will be RMS? RMS will be this V1 square, V2 square up till Vn square divided by n with an under root. This is VRMS. Fine, this is the value of VRMS. So root is also done. This is how you calculate root mean square speed. All right. Now from this formula class, we'll put volume as L cube. From here, you put volume as L cube. So your formula for pressure, you have this formula, N mn V square. This is RMS. This is root mean square, RMS. Put this entire here. And instead of volume, you can put L cube as well. Fine, you can put volume also, you can put L cube as well. And for RMS, perform the calculation from the above steps. Fine, perform the calculations from the above step. If you know number of volumes, number of molecules per unit volume, this you know, P is equal to 1 by 3 mn V RMS square by V. If you know what is this term, N by V. So directly, let's say N by V is some small n. So this becomes 1 by 3 n m V RMS. This is how you manipulate. That completes your lesson as well. This was a very small, very easy, very theoretical lesson. Just remember the postulates and 1 or 2 formulas, that will be sufficient. The other chapter that we'll start on Friday, because you didn't have your class on Monday, no? So on Friday, we will start with thermodynamics. That is a very important lesson. There you have very real good concepts. So we'll start with that on Friday. But for today, this is all about kinetic energy. For if pressure comes, you have to show these steps: momentum, force, how have you got pressure. All right, these are the steps that you have to follow. Note it down. Wherever doubts you have, you can ask. So all those who have completed, you can leave. All right. Tomorrow we'll in the next class we'll continue Friday.
Thank you, ma'am.